So you see, we had discussed in the last class automated storage and retrieval system, right? So it's a continuation of that. Where are we going to apply it? What are the applications of automated storage and retrieval systems? So generally, what we know of, or what is generally heard of, is warehousing, right? Warehousing and distribution operations like Amazon. So they generally are more popular in using these automated storage and retrieval systems. But it can also be used for raw material storage of work in process in manufacturing. Okay, when it comes to the manufacturing context, we are storing it for work in process. So basically, those incomplete parts, okay, or sub-assemblies, or even completed parts, okay, if you want to store them, okay, before the customer demand request for shipment, you have to store it, right? Like for the customer who has placed the order of, for example, 20 parts, and those parts are produced, but the customer has not what do you call taken the order yet, so you have to store them somewhere. So that, so not just work in process part, but also completed parts also, okay, but mostly work in process. You will store it because they are incomplete. Some operations have to be performed, okay. Some have been performed, some are still to be performed. So those operations, those parts which are in progress, or that's what we call work in process, right? So to store them, okay, three application areas of interest: unit load storage and handling, order picking, and work in process storage. So basically, unit load storage and handling, what we saw in the last class, that is unit loads, right? To store unit loads, okay, they are one unit, okay, although it could have so many what do you call cartons or boxes, okay, or many components, but they are packed into one unit. That's why we call it unit load. So because it is easy to handle, right, unit loads, that's why. So for unit load storage and handling, what we saw in the last class. And order picking, okay, that is basically in your basically, if for example you have an assembly to make, okay, that I told you an example of man on board system, right? This one, person on board ASRS. Basically, this person will ride on the storage retrieval machine, and he will go to that particular spot where that what do you call components of the assembly are. One may be here, other may be there. Okay, he will collect it. That's why we call it order picking. Okay, this case, or even the case of in warehouse also. Okay, for example, Amazon. Okay, I'll show you one video, hopefully, so that you can understand what is order picking. Okay, so that basically they are placed at different places, right? So you want to have some items from this bin, some items from that bin. So that's what you call order picking. Okay, and the last one, work in process storage, as I told you, right? All that, the manufactured goods which are not complete, okay, to be able to store them, so that, because some operations are to be performed, right? Those workstations are busy. So instead of making them wait on the line, okay, before the machine workstation, you're trying to store them somewhere, okay, because maybe the workstation is busy for maybe 1 or 2 days. So that's what it becomes important to store them, and that's where automatic storage and retrieval system comes into picture. Is it clear? No doubts, right? Okay, you see, work in process storage, okay, that's important, especially for our manufacturing context that we are seeing, right? We're looking at how automation is implemented in manufacturing context. So work in process storage, work in process is desirable for balancing workloads throughout the factory and in order to meet the demands for short-term fulfillment of customer orders, right? So we want to balance the workloads, right? As I told you, one workstation would be busy, so you have to manage to be able to store that. So to balance workloads throughout the factory, and because no machine should be overburdened, right? And no machine should be starved. So basically, this work in process, right? We are trying to store it so that we can supply it to be able to balance the workloads. And work in process is inherently inefficient and needs to be minimized, right? Just a minute. Okay, so you see, work in process, we want to minimize it, isn't it? Because why would we want to take the what do you call, burden of storing it? Okay, right? The less the better, isn't it? That's why we're saying it is inherently inefficient and needs to be minimized. We want to minimize it as much as possible. It cannot be eliminated entirely. That's a fact. Okay. Hence the requirement for work in process management and the use of automatic storage and retrieval system for this application. You see why this comes into picture. Okay, we are trying to justify the need of an automated storage and retrieval system. Okay, because working process cannot be eliminated and we have to manage it somehow. So that's where this comes into picture. For high production operations, large capacity ASRS technologies may be used for staging and sequencing the work units as per the production schedule to achieve increased production efficiencies. You see, when it comes to high production, you want to produce it at a mass scale. So you see, too many components are required, and for just one product, many components would be required, right? Hundreds of components would be required, and those are to be produced at different machines. And those machines will have different orders, right? Each machine will have to make one component of one product, another component of another product. So you have proper scheduling in place, right? So as per the production schedule, you're trying to stage it and sequence it. Okay. So all this is possible only when you have some storage, right? So this is very important when it comes to high production operations. Okay. Is it clear? This slide? Okay. You see, what are the reasons to introduce work in process automated storage systems? Okay. Buffer storage, we already discussed, right? Analysis of transfer lines with buffer storage. So a buffer storage is basically where you store it. So why not use that buffer storage, right? Between, to be something of a different nature, right? Not instead of having it between two machines, okay, between two workstations, like what we have seen earlier, right? That's what we saw, that there is a buffer storage in between two workstations. So instead of having it here, why not have a dedicated storage? That's what we call buffer storage. Okay, that's why we're calling it buffer storage in production. Okay, so that all of the parts which are, like for example, this machine is taking too many what do you call, hours to complete product. So how will the parts wait here? Okay, and let's say this machine is, the production rate of this is high, so more and more units will pile up, isn't it? So then you have what is called blocking. Okay, because it cannot forward, right? the completed work parts. So because the production of rate of production is high here, it will output more and more products which cannot be stored because your buffer storage is of a limited capacity. So instead of having a buffer storage for every other workstation between every other workstation or departments, you are having it solely dedicated for storage. Okay, that's why we're calling it buffer storage in production. Okay, and support of just-in-time delivery. Okay, you see there's a concept of just-in-time production, right? Have you heard of it? Just-in-time, JIT, just-in-time production. Basically what it says is you deliver the components right when you need them. Okay, but the problem is actually there may be, right, suppliers who are not who will not supply on time, right? So there are risks involved, right? So to overcome that, to compensate for that, we store it. So that's why we call it support of just in time, although it is against the very fact of just in time production, okay, concept. But to be able to manage the risk, right, owing to the failure of delivery by the suppliers in just in time system, these storage systems may be installed as storage buffers for incoming materials. Okay, so that we don't have this problem of stock out, that there is no stock supply and the production order is yet to be delivered, right? So that and kitting of parts for assembly. The storage system is used to store components for assembly of products or sub-assemblies. When orders are received from storage, they are put together into kits and delivered to production, right? So basically to be able to have those kits, right, to store so that we can have the assembly or sub-assembly of products. Okay, even that is another reason. Clear? Compatible with automatic identification system. You see, because you want to store it, you have to identify, right, which product is going where. The computer should know what product is at what rack, right? And so that information has to be, so you have to have compatibility with automatic identification system. So there should be an identification system, basically a barcode system, so that every other product that you're placing in the rack, okay, should be identified by the system, right? So that it can store the data that so and so product is there. So as and when the system requests it, right, as per the production schedule, you will get it from that particular rack. So there has to be an automatic identification system also. Computer control and tracking materials, right? Very synonym, I mean, very much similar to the previous point, that you have to have the computer control and tracking, right? And how are you going to achieve it? With the help of this identification systems. Support of factory-wide automation. That's basically your total automation, right? We talked about enterprise level of automation, right? Or plant level of automation. So this is where that concept comes into picture, right? Because you want to have total automation. Not just the workstations are automated, but also the material handling, right? Which is supplying the materials, which is handling the materials, is also automated. So an appropriately sized automated storage system is an important subsystem in a fully automated factory, isn't it? You cannot have manual work handling when you have total automation. If you're claiming total automation, that includes your material handling also. Okay. So I hope this is clear, right? The reasons of automated work, automated storage systems, especially for work in process. Okay, another point about the principles of material handling. Okay, let us have a look at that. So as per the Material Handling Institute, okay, that is based in USA, so they have laid out the 10 principles whenever you're designing a material handling system, right? This is about design of material handling systems, okay? So the 10 principles that you have to take into account, okay, so that you can better design it, okay. So first one is your planning principle, right? All material handling should be the result of a deliberate plan. There has to be a dedicated plan for it, okay, which should consider the needs, the performance objectives, the functional specifications of the proposed methods, okay, so that they should be completely defined right at the very beginning, at the outset, okay. So what are the objectives? How much load are you going to, I mean, how much is the production rate that you're trying to cater to, okay, and functional specifications, what exactly are the loads that you can handle, okay, all the different specifications of the storage retrieval machine, right, of the conveyor system that you're using, of the AGVs, right, and the needs, okay. This starts with the need, right? Why do you need it, and what capacity of the production plant is it? So there has to be a complete planning involved. That's the first principle. Second one is standardization principle. So basically it says that all of that material handling methods, equipment, controls, and software should be standardized within the limits of achieving overall performance objectives without sacrificing needed flexibility or modularity and throughput, anticipation of changing future requirements. So it says there has to be standardization, right? Standardization because uh, your equipment, for example, one equipment, if you have taken customized one, that may not be able to be, that will not be compatible with other devices in your system, right? So standardization as much as possible, but without sacrificing needed flexibility. So there has to be flexibility also, right? If you are changing some products, the product design is changing, for example, so the number of components would change, or the size of the component would change. So all that has to be considered, right? Anticipation of changing future requirements. So standardization, yes, but not too much standard so that you lose the flexibility, okay. So that, and work principle. Material handling work should be minimized without sacrificing productivity or the level of service required of the operation. That is basically your number of work steps should be minimized, okay. If you can minimize like the moves, okay, you have to see each and every individual move. How is it moving? Can I, if it is moving from left, right, and then incline like that, can I make it to be, can I combine two or three operations to be one or two operations, okay. You see, we talked about this strategy, right? Combine operations. So this is basically that you have to minimize the work that you're doing so that you can save on power, right, and the time also. That is the basic thing that we are trying to minimize, to be able to do it efficiently within a lesser amount of time, right? So that is why we are saying without sacrificing productivity or the level of service required of the operation. So it should not be too much simplified, right? So that, and ergonomic principle. You see, about ergonomic principle, human capabilities and limitations must be recognized and respected in the design of material handling tasks and equipment to ensure safe and effective operations. Basically, you have to consider the operators who are involved, right? Or the systems which are involved. For example, uh, the accessibility, okay? Uh, and even you see, when you're trying to design that system, if you're trying to make it more big, okay, and not accessible, then that loses the purpose, right? So it should be taken in, that should be taken into account, not just human factors, but also the machine factors. So human capabilities, okay, if for example humans are involved, then and also the design of that system, okay, the interface of the work handling system, okay, also has to be taken into account, that the operator can understand. If he wants to take over, okay, from automatic to manual, then he should be able to understand, right? And so when you're designing it, you have to consider all of these so that we have safe and effective operations, right? Because this also takes into account, what do you call this, safety, right? All those sensors, etc., so that we have safe and effective operations. Clear? Ergonomic, right? That's about ergonomic principle. Other thing is your unit load principle, okay. That is basically unit loads shall be appropriately sized and configured in a way which achieves the material flow and inventory objectives at each stage in the supply chain. So I told you, right, you have to make it unit load as much as possible. Basically, if you can, because unit loads are easy to handle, isn't it? If you're trying to handle individual boxes, that is difficult. If you're trying to make it a unit load, then that becomes easy, isn't it? That is why those AGVs in the assembly, I'll show you one video in the truck assembly, that they will take it to the different stations, right? That's basically a unit load. So each and every component is added, okay? So that is another example. And also we saw the AGV of unit load yesterday, right? All those rollers, they're able to slide that unit load. So that is what we're talking about. The size of that should be appropriately designed, and and accordingly the AGV should be selected. Okay. Space utilization principle. Basically, trying to effectively and efficiently use the space, right? And this is where that comes into picture. That you may have vertical columns, right? That I showed you one example. You see, you're placing it quite high, but let's say you're trying to make it so high that there may be some issues with the design, right? That even the in-depth, like the, what do you call, the shuttle has to move inside, right? So if it is too deep, right, then it will be difficult, isn't it? The traveling time, etc., will be what do you call, affected. So and also, if you're trying to make some very, if you're trying to leave very minimum clearances between this machine and the racks, right, then that will be a problem. Because you see, if you have designed, if you have made some space considering some unit load as a standard size, and now sometime in the future that you are having some a bigger unit load, then your clearance will affect, right? I mean, your unit load will what do you call, uh, what do you call that, it will drag, right? Whenever you're trying to handle a bigger load, your space is not sufficient here. So considering all of that, your future requirements also, you have to take into account how better can we utilize the space. Okay, not to, what do you call, accessibility problem shouldn't be there, and it shouldn't be over designed also. Okay. Okay. And system principle, material movement and storage activity should be fully integrated to form a coordinated operation system which spans receiving, inspection, storage, production, assembly, packaging. You see, all these are different departments, right? Unitizing, order selection, shipping, transportation, and the handling of returns. So it should be integrated, right? There should be coordination between all of this. Only then can you call it completely automated, right? That the receiving department, okay, should have the data of where uh, should it be placed and what units are required. Inspection station, storage station, production, assembly, all the different departments. So the assembly department, for example, has to assemble some products for a production order. Okay, then they will call, for example, one assembly has 4 sub-assemblies. Each sub-assembly is having 10 to 15 components. So they all have to be, what do you call, drawn from different places, right? They have to be called from different places in the storage system. So that requires a coordination between assembly and storage system. Similar is for packaging, right? As and when it is required to be packed and sent, then you have to have a coordination between the storage system. So that's why we're calling material movement and storage activity should be fully integrated. Uh, and then automation principle, material handling operation should be mechanized and or automated where feasible to improve operational efficiency, increase responsiveness, improve consistency and predictability. You see, automation principle, that is what basically we are trying to do. I mean, throughout, isn't it? So wherever possible, it should be mechanized, and wherever it is not feasible, then you can make it what do you call manual. Okay, so that we can have this efficiency, right? Wherever we want, we can increase the efficiency and responsiveness of the system, and consistency and predictability. For example, if you have everything as per the schedule, we can predict that so and so order would be ready by like so and so date, right? So that and the responsiveness of the system, right? When you have diagnostic features installed in the system, then how you're responding to it, and even the response of the what do you call yes, the maintenance, etc. Okay, so that it can be corrected. So that and consistency and predictability. Environmental principle. So basically, this takes into account uh, that you have to use yes containers which are biodegradable, okay, or reusable. Okay, so that we have these environmental aspects also considered, right? And energy consumption, even that is another factor, right? As I told you, we want to have a very lean kind of system, right? Only those which are required or essential will be used. Okay, so that we can save on energy because the weight of the equipment that the system is handling is less, therefore energy consumption would be less. Okay, so when you're trying to design it or select a system or equipment, you have to look at the environmental aspects also. Okay, life cycle cost principle, that is a long-term what do you call analysis. A thorough economic analysis should account for the entire life cycle of all material handling equipment and resulting systems. So you have to look at how long you are going to use this system. Okay, and so the economic analysis of it. Okay, so when can we achieve, when can we achieve, yeah, when can we achieve the returns on investment, ROI is what we call it, right? So that is also taken into account when it comes to life cycle cost principle. Okay, is it clear, these 10 principles of material handling? Yes. Now let us see a video. Okay, uh, the meeting is still to end. It'll take 2 minutes more. So meanwhile, if you have any doubts, you can ask. Okay. You see about that unit load principle, uh, that may change, right? From department to department, it will change. So you have to take into account the standard size